Hello, guys. Welcome back. Good evening, all of you. Good evening from India, rather. Okay, so what we will do today is, can you just tell me till what point we have done the corresponding problems in IOQM? I think last day someone else has taken the class. I think people he has done his number today. I think he has done till 19th. Is the 19th question done in prior of IOQM? Or I will discuss it again, guys. Tell me. Let's discuss the problems from 20. Okay, 2021 I came to 20 problem. I think few more problems are left till 30. So let's discuss from 20. So 20th problem is really easy problem. Let's see how what's the problem is all about. It's just unitary method problem. Okay, the problem tells us that the following, that okay, so the problem tells us that we have, okay, okay. Hi, hi, hi. Hello. Good evening. The problem tells us that we have started. Just give me a minute. Let me share it. Uh, okay. The problem tells us that. Okay, we will discuss it again. I have copied the question. No worries. The problem tells us that a group of women working together at the same rate can build in 45 hours. Okay. Then when the work started, all the women did not start working together. Okay. Try to read it very carefully. A group of women started working together at the same rate and build a one wall in 45 hours. Okay, a group of women. When the work started, all the women did not start working together. They joined the work after a period of time, one by one, at equal intervals. Once at work, it stayed till the work was complete. If the first woman worked as many five times as many hours as the last woman, then how many hours did the first woman work? Okay, so how do you approach this problem, guys? Tell me. So it's telling a group of women working together at the same rate can build in 45 hours. Okay, when the group work started, essentially we need to find something such that we can calculate what if they can start working together. Okay, we must use this data, right? So how can we use this data? A group of women, about a group of women doing this. How can we get this data? Tell me, how can you use this data? Any ideas, guys? Okay, so this is how. So let's suppose the n woman. Okay, suppose the n woman, and what do we get? That each woman, try to understand each woman का 1 hour work का rate कितना है. Okay, try to understand this very carefully. So n women are there, and they do a wall built in 45 hours. Okay, together. So therefore, by integrating that, one woman takes 45 n hours times n hours in same, right? So therefore 1 hour is equivalent, okay, 1 hour is equivalent to what? Is 1 by 45n, right? One by 45n, right? So how do you exactly do this, guys? Tell me. So if it's 1 by 45n, So n people work for 45 hours. So therefore, one person works one to complete the same work. They need to do in 45 times n hours. Okay. So therefore, equivalently, 1 hour is equivalent to 1 by 49 n women, right? In some sense, right? So yeah, that's the idea. So therefore, when the work started, all the women did not start working together. So they joined the work of over a period of time, one by one at equal intervals. Okay, that's the essential idea. Number of women is not given, but let's see how we can do that. So therefore, we need to use the apply what is called the corresponding AP for result, right? So suppose a woman starts working here, the first woman, and then after D time, the next woman starts working, and then after D time, another woman starts working, and the D time, the other woman starts working. Okay, so yeah, that's the idea. Okay, so we just know that this woman ka work time required. Okay, the number of hours that woman worked. Okay, is same as is 5 times the last woman ka work. Okay, number of hours. So the number of hours, what, so let's try to count the number of hours from here. How do you count the number of hours from here? How do you count it? Try to understand that very carefully. So wait, 5 times the last moment's work, right? So let's say this one. So let's say this woman did for t hours of work. Okay, let's say this woman did t hours of work, and there are n women, right? So here the n minus 1. So therefore, t minus n minus 1, each work for d times less, right? D interval less. So therefore, this woman worked for t minus n minus 1 times d, right? Time length. If this woman worked for t, this woman worked for t minus n minus time 1 times d. So what we know, that t minus n minus 1 times d ka 5 times is equal to t, right? Is equal to t. That's the idea of this problem, that first woman worked 5 times at the second woman. Okay, the last woman. So this is the idea we have incorporated over here. Okay, we got this idea. Now we need to calculate this. Okay, let's try to find out what's next. So from here we need to know what we need to calculate, that what is the time required for the first woman to work. How much hours did the first woman work? Okay, that's the thing that we want. So essentially we want to bring in what we want to bring in we want to bring in t is equal to something, right? So this equation, right? But observe that we didn't use the information 45 hours over here. So how do we use that? So we are going step by step how to approach a problem. Okay, we first use this information to get this equation. Want to use this information now to get the other equations. Okay, the other equations, so that we get in terms of the whole thing. Okay, so let's try to understand what we got over here. Okay, do in terms of t's. If you just replace it, you will observe that if you just do it, one second, if you just do it, if you just replace all of this, so you get that 4t is equal to 5 times n minus 1 times d. Okay, if you just cancel t on both sides. Okay, so therefore you get the following, that 4t is equal to 5 n minus 1 times d. Now observe this very carefully. Observe this very carefully, that how do you do this? How do you do next? What do you do next? So you need to put in somewhere 1 by 45 n, right? 1 by 45 n. So how do you really put that over here, guys? Can you tell me, how do you really put that over here? Where do you rather put it over here? So each woman ka 1 hour work is 1 by 45 n. I'm sure. So if the first woman starts at time, see, the first one works for time t, it's told that each woman started working after d, after equal intervals, say d minutes or say whatever d hours, okay. So therefore, if the first one started working at if worked for t hours, the second one worked for t minus d hours, because the second one started after d minutes or d hours. The third one will start working after t start have worked for t minus 2d hours. Okay, that's the idea. The third woman has worked, fourth one has worked for t minus 3d hours. Therefore, the last woman has worked for t minus n minus 1 d hours. Okay, because every woman is starting, next woman is starting after d hours. That's the idea. Okay, so how do you exactly do that? So you got 4t is equal to 5n minus 1 times d. So you need to use the information now. So this is how we get this. 5 times the first one, last moment ka work is equal to initial moment ka work time. So how do we use the information that 1 over 1 hour ka work is 1 by 49? 45n, sorry. How do you use that? Tell me. So what do you get from here? What do you get from here? Oh, because there are n minus 1 gaps over here, guys. N minus 1 gaps. Did you understand? Did you understand, guys? So how do you do the next part? Yeah. So what? How do you do next? Tell me. Yeah, exactly. How do you do the 45n time? How do you use that over here? Tell me. Any ideas, guys? So it's not really good to like talk fully. So a group of one work together can build a wall in 45 hours. Okay. So if therefore 1 hour ka work is equivalent to, so we need to find t from here. Okay. How do you do that? Suppose all the women have worked together. So then what you have got? So 1 hour is equal to 1 by 40, 1 by 45n. So yeah. So n is equivalent to 45 hours in some sense, right? So what is equivalent to 45 hours? Tell me. What is equivalent to 45 hours? So n woman working is same as 45 hours, okay? But they're doing it the whole work. So essentially, what is the idea? So t, also the t, okay, so if all the woman has worked for t times, t time, okay, or all the women have worked for the entire time. What is the total number of hours they worked? Can you tell me? What's the total number of hours they worked? So each woman, first woman worked for t hours, the second one worked for t minus d hours, the third one worked for t minus 2d hours, the fourth one did for this, right? Karte karte t minus n minus d hours. So if you sum up this, what's the, so it's nt is there, right? N woman n minus d times 1 plus 2 plus dot, 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 n minus 1. So if you add this up, you get nt minus n d n minus 1 by 2, right? This are a number of hours they worked. Okay, so this is exactly equivalent to 45 hours, right? Because this is the total number of time they take to build 45 hours. I mean, this is not equivalent to 45 hours, I'm so sorry. I mean, rather, okay, so this is essentially the total time taken by them, right? Total time taken by them. Yeah, we can substitute n in the equation. Okay, if you substitute n in the equation, so to understand what we are really doing over here, guys, you have to understand what you're really doing over here. So this is the total time taken by the woman, right? So what you get? You get n times 2t minus dn minus 1 by 2, right? This total number of hours taken by this, right? By the woman. So what we know, total number of hours taken, okay? So what do we know about this, guys? Tell me. How can we do this now? So this time, this total number of hours taken by the woman, okay, this time is same as 45n, right? Total number of hours taken by the actual woman. So you need to understand everything over here. N woman took 45 hours, so therefore total number of hours taken is 45n, right? Do the whole work. So therefore total number of hours taken here is essentially equal to 45n. Yeah, so total hours. So you got this one, right? So n gets cancelled. N by 2 times 2t minus d minus n minus 1 is equal to 45n. So n get cancelled. So you get 2t minus d by n minus 1 is equal to 90. You get. And the initial one, so you got that 40 is equal to 5n minus d. 40 is equal to 5n minus 1 times d. Okay, so just multiply 5 by here so that you get this one. So you get 10t minus 5dn minus 1 is equal to 450. Okay, and 4t is equal to 5n minus d. So therefore 6t here, you just replace it over here, is equal to 450. And you get, I think, t is equal to 75, I guess. Yes, 75. All we understood this one, guys. This is a very simple problem. Yeah, that is a different problem solving session. This is a live one, okay? That is for our internal students. So we have a regular problem solving sessions going on in Chinta for our internal students every single day for 1 hour for both ISI, CMI, and for both IOQM for the next year, okay? So yeah, so please talk to the support team then, Anushka. Please talk to the support team. I mean, please talk to Shabana ma'am, Namrata ma'am. Okay. Okay, so let's move on to the next problem, guys. The problem number 21. Total number of fixed amount of, okay, I will just copy and paste the problem over here. I have copy paste the problem over here. So yeah, so that understand this very carefully, guys. A total number of fixed amount of n rupees. So the previous problem was really easy in terms of how to approach that. It was really easy. Okay. Okay, so let's do this problem. So total number of fixed amount of, okay, fine. So a total number of fixed amount of n thousand rupees is given to 3 persons, A, B, C, every year, each given a amount proportional to their age. In first year, A got how? Okay, this is an equation problem. So A and B each every year. Okay, each year and I'm given an amount proportional to her age. A got half the amount. First year A got half the amount. First year A got 50%. Okay. So initially, let's say initially the age ratio was this. Okay. Next year the age ratio was this. Right? Every year it was increased by 1. And it went on like this. So therefore, uh 50%, that means A by A plus B plus C is equal to half. That is, A ka ratio is half. Okay, that is what the idea is all about here. And yeah, so also you can do it like this: A plus B plus C is equal to 1 and A is equal to half. Okay, you can also do it like this. So okay, A plus the ratio we are considering now. So now A plus 1. Okay, fine, good. Let's see it now. A got 6/7 when the 6/7 payment was made. That is first year, second year, third year, fourth year, fifth year, sixth year. That is A plus 2, A plus 3, A plus 4, A plus 5. When the sixth payment was made, A got 6/7 of the amount that she had in the first year. So in the final year, it was A plus 5 by A plus B plus C plus 15. Okay, and she got A by B A plus B plus C times N, the amount she got in the first year, or rather in the first year she got it N by 2, right? So in the first year she got N by 2 into N, you can multiply over here. Rather you can like N by 2 times 6/7. Okay, 6 by 7. So you can get N get cancelled over here, okay? N is not really important over here. So it's got half of 6/7 of the initial one. Lovely. B got 100,000 less than the first year. 1,000 less than the first year. Okay. 1,000 less. So 1,000 N we got B by A plus B plus C. Okay, times N minus 1,000 is this time, that is B plus 5 by A plus B plus C plus 15. Lovely. Okay, and C got twice she had of the first year. Is C plus 5 by A plus B plus C plus 15 is equal to twice of C by A plus B plus C. Lovely. So from here, this is a C wala equation. From here, observe that suppose let's assume A plus B plus C is equal to 1. Okay, you can easily assume that. Okay, doesn't matter. So you get that C plus 5. So from here, you get the following equations. This A is equal to half, you know from here. Okay, from here, A is equal to half. So this is done, this equation. From here, you know that A plus B plus C is equal to 1. So A plus half by, am I doing something correct? Am I doing something wrong? I am. Let's see. Uh, Initially, okay. Um, um, um. Oh no, we cannot take A plus B plus C is equal to 1. I'm so sorry. Because A, yeah, we cannot really do that. A is the years. Yeah, we cannot really do that. Okay. Cannot do that. What really happened? Just give me a moment, guys. Yeah, I hope everything is fine. Yep. Okay, so let's see over here. Um, okay, we cannot really assume this because A, B, C are ages. Okay, we have taken that, so we cannot really assume this one. Okay, this is not correct. So let's see this over. A by A plus B plus C is equal to half. We have this equation and we have this equation. So you get that A plus B plus C is equal to twice of A. Okay, so you just put it back here. So you get, I think you will get A from here. You get from here that A plus 5 plus twice A plus 15 is equal to 6 by 14. So you give it over here. 14A plus 70 is equal to 12A plus 90. And you get that A is equal to 10 over here. Lovely. So you got A is equal to 10. Very good. Okay, nice. If A is equal to 10, okay, that's quite interesting. Let's put it over here. A plus b, a is equal to 10. So a plus b plus c is what? A plus b plus c is 20. Lovely. A plus b plus c is 20. So you can put easily over here. Now put a plus b plus c is equal to 20. That is c plus 5 by 35 is equal to twice c by 20. Okay, so again 10 over here, you get that 10c plus 50 is equal to 35c. You get it from here. 25c is equal to 50. That is, you get that c is equal to 2 over here. Lovely. So you got c is equal to 2 also. If you got c is equal to 2, then you need to find a b. B is equal to what? B is equal to 8 then. Lovely. That makes a lot of sense. It's c. A is gets half of this. Okay. Lovely. So let's find n now. N is really easy to find now from this given equation. So b is 8. So 8 over here, put 20 over here. 8 over here, b put 8 over here, 20 over here, and you get n, I think. So you get 13 by 35 is equal to 8 by 20, 8n by 20 minus 1000. Okay, this is not quite good. I think it's in terms of 1000 only. Not sure. I think this is in terms of 1000. Yeah, in terms of 1000. Oh, yeah, in terms of 1000. Yeah, you're right. So therefore, you get that. I think you get 48 by 35 is equal to 8 by 20. I'm doing something wrong, I guess. Or maybe not. No. And 1000 is this. Anyway, so we get 8620 over here. So 120 by 35. I don't know what is why I'm doing some mistake or not. Must have done some mistake. I don't know. Okay. Anyways, the idea is in like incorporating this whole problem. Okay. Let's not waste time. I think you got the idea. I think I did some calculation mistake over here. Okay. Let's move on to the next problem. It's a very easy problem. The other problems, harder problems. Okay. This is another really beautiful problem, guys. The geometry problem. So geometry problem takes some time, though. I think we can complete the IOQM next day. Okay, so ABC is a triangle and PQP are the feet of the perpendiculars, okay? And QS is the perpendicular. So if you try to draw the diagram, guys, so I will tell you something. If you try to draw the diagram with your hand only, okay, try to draw the diagram. Okay, so let's try to at least draw the diagram somehow. 1 second. There are mosquitoes all around. A, B, C. P are the feet of A to external angle bisectors, okay? Okay, sounds good. So here's the external angle bisector. Let me draw the different color. External angle bisectors and internal angle bisectors, external angle bisectors, and oops. Okay, lovely. Okay, so yeah, you can understand these are in center. Okay, anyways, so let's try to draw perpendicular over here. So A से perpendicular आ रहा है on internal angle bisector and external angle bisector. So let's take this. I think it will be a bit slanted. I'm not sure. Like this, yes. Okay, so if you just draw a perpendicular over here, you will get a perpendicular like this. If you draw a perpendicular over here, you'll sort of get a perpendicular in this format. Okay, it sort of looks like a perpendicular. Again, if you try to draw a perpendicular, you will get it over here. And again, if you try to draw a perpendicular, you will get it over here. Okay. If you try to draw it, man, guys, so if you see that you will sort of lie on a straight line, okay, you will sort of find that this PQRS. Okay, if just with straight hand only, like this just is for like free hand only, okay, if you get that. So therefore, our first aim should be to prove that PQRS are collinear, okay. That's the observation. So this is the idea you get. Some geometry, what you do is that you try to get ideas, guys. Okay, you try to draw the diagram, you try to get the ideas what's really happening. So you first draw the diagram and you give an intuition. Okay, this may be collinear, because otherwise it's really hard to handle so many triangles now. So to prove that easy stuff, we will go now to prove that easy stuff. Okay, that why this PQRS maybe correspondingly um collinear. So the idea we will use is the following. Suppose these 4 points are here. Okay, so when we will say these are collinear, okay, we will say that, let's call this PQRS. So we will say that sort of all these are parallel to all these lines. Okay, PQ is parallel to QR is parallel to RS. Okay, similarly QS is parallel to PR. Okay, all the parallelity conditions, that means all these are parallel. Okay, and this is 90 degree, that means this must be a straight line. Okay, all this must be true. Okay, so we will try to use a similar idea over here to prove that they are actually um they're actually the correspondingly the, like, they lie on a straight line. Okay, so we'll use some ideas over here, guys. Let's see. So why is that 45n? Okay, I missed this message for a long time back. 45, as I told, 41 hour is equivalent to 1 by 45n. Okay, so here this 45n is coming, that therefore if in woman does that for 45, see, when woman does that for 45 hours. Okay, so therefore total number of hours taken is 45 n hours, right? By total number of women. Here the total number of women worked for this how many hours they work. That must be, that means essentially it took 45 n hours. That's the idea. The previous problem is this. You can take a screenshot of this. And okay, let's come back to this problem. So we will show that. Okay, let's that these are all parallel over here. Sure, I will name that. I will give a good picture over here. Just give me a moment. Okay, so I hope all of you can see the picture over here. How to approach this problem now? So we'll first show PQRS are actually collinear. Okay, we'll first show that. How can we show that? Let's try to explore that. How can we show that? These are all perpendiculars. Okay, let's mark them. These are all perpendicular external angle bisectors. The internal angle bisectors. Okay, this is like this. I is in center. Okay, lovely. And this is also, this is a 90 degree angle, internal angle bisector, external angle bisector form a 90 degree. The first observation is, guys, this very importantly, I try to understand this, that this is a cyclic quadrilateral AQI. This one is cyclic quadrilateral. AQRI cyclic quadrilateral. Okay, because some of the opposite angles are 90 degree. So this is a cyclic quadrilateral, but how can we use that, guys? How can we use that? So observe that this is an incenter. Okay, this is an incenter. So let's see what we can really do. But the main thing observation is that this is 90 degree, this is 90 degree, this is 90 degree. Okay, so what we're observing, that therefore when this happens, the other one is also 90 degree like this one is also 90 degree like this, because of the perpendiculars. So therefore we got two rectangles. APBR is a rectangle and AQCS is a rectangle. Is a rectangle, lovely things start happening. Okay, lovely things start happening. So that means this is parallel to this is parallel to this, lovely things started happening. Okay, so now we are on the mission to prove that this PQ and this stuff are actually parallel to each other. Okay, that's our mission now. So let's see. Just give me a minute, guys. Okay, so how do you actually show that? That's interesting. Okay, so we can show it in the following manner. Um Yeah. Okay. Okay. So observe that P A R. So observe that P A B B I is a rectangle. Okay. It doesn't mean that P Q and Q are on a straight line. Don't forget this. We need to prove that P Q and Q are on a straight line. Okay. So this doesn't mean that P Q R is the other diagonal. Okay. Doesn't mean that. Okay, try to understand this very carefully. It doesn't mean that PQR is the other diagonal of this rectangle because we don't know whether they are on a straight line or not. We will prove it now. Okay, so how do we prove this now? How do we prove this now? So we will first prove that PR is actually parallel to BC. PR is actually parallel to BC. Okay, so PR is sort of think as if PR is the diagonal. Okay, that makes sense. PR is actually the diagonal. We want to show that Q actually lies on that. Okay, so therefore what we get that PR is parallel to BC. How do we prove that PR is parallel to BC? It's really simple, guys. PR is the other diagonal, so try to understand this. So this is the idea. Let me draw it exclusively for you. So APBR, okay, this is the angle bisector, okay, and this is the other angle you got. So these are the two equalities, okay. These are two equalities you have, and therefore you get that this is a right angle triangle. You know this PR is this. So how do we use that? This is equal to this, okay. And what else do you use? Tell me. How can you use that now to show that PR is parallel to this one? How do we use that? So if PR is parallel to BC, okay, that means this must be also equal. This must be also equal to this. That is, this angle must be equal to this angle, right? So how do we show that? It's really easy, not really hard. How do we show that? So therefore we need to do some angle chasing, right? We do some angle chasing, right? So angle PRB is equal to angle PAB, right? Angle PRB, let's call this angle PAB is equal to angle PRB, right? Why is this true? Can you tell me? This angle must be equal to this angle. This makes sense because this is a cyclic quadrilateral. Rectangle is a cyclic quadrilateral. That makes sense. Right? This makes a lot of sense. So this angle must be equal to this angle. Okay. It also makes sense, a lot of sense. So also this angle must be equal to this angle. You know that, right? But observe that this angle must be equal to this angle because these two are parallel. And this two is a cyclic quadrilateral. So this angle must be equal to this angle. So all these angles are equal. Therefore, what do we get? PR is parallel to BC, right? Therefore, get a PR is parallel to BC because this angle is same. PR is parallel to BC, you get. Similarly, you get that QS is parallel to BC. You get PR is parallel to BC. You get QS is parallel to BC. Okay, just we need to prove that now QR is parallel to BC too. Then it will. So you prove that this is parallel to BC, this is parallel to BC. Now to show that this other thing is parallel to BC. Okay. So if these two things are like this, suppose PR is this and QS is this. Okay. We need to show if we show that QR is not parallel to BC. QR is only parallel to BC if QN lies on this are collinear. Okay. Therefore, the next part will be showing that QR is parallel to BC. Yeah, APBR is a rectangle. AQCS is a rectangle. You're right. Then what we will do next? So that's the idea. So how do you show that QR is parallel to BC? It's very easy. QR is parallel to BC. Try to observe this cyclic quadrilateral now. AQIR. AQIR. So it show that it's QR is parallel to BC now. Okay. So let's show QR is parallel to BC now. Try to focus, forget about everything. Now try to understand that QR is parallel to BC. How do you do that? So I is the in center, right? I is the in center, right? So sort of we need to prove the following, that this angle is actually equal to this angle. So what is this angle? Do you know, guys? In a right angle, in a triangle, if these two are in centers, this is say b by 2, this is b by 2, this is c by 2, this is c by 2. So this angle is 180 degree minus b by 2 minus c by 2, that is b plus c by 2. Okay, so if you replace b plus c as 180 degree minus a, you get that it's 90 degree plus a by 2. This angle is 90 degree plus a by 2. Okay, so therefore this angle is 90 degree plus a by 2. So this angle is 90 degree minus a by 2 because it's cyclic quadrilateral, right? So observe this very carefully now. Take this angle, take all down, delete all this, okay? Forget all this stuff over here. So observe this very carefully. We are 90 degree, 90 degree. We need to show this angle is equal to this angle, right? B by 2. This is B by 2. So this angle is actually equal to this, right? This angle. Right? By cyclic quadrilateral assumption. Oh, I'm so sorry. Is it true? No, sorry. This is not true. I'm going to show this. Okay, let me think just a minute. Yeah. So QRI is equal to QAI, right? This angle. This angle is equal to this angle, right? These two angles are equal. You need to find this QAI. How do you find this QAI now? Okay. So let's try to find out this angle first. So you know this angle is A by 2, right? This angle is A by 2. Let's try to find out this angle. Okay. How do we find it out? Give me a minute. QAI. So QAI is QAC minus, yes. Right. So QAI is this minus this one. Yeah, this one. If you just join this one, guys. QAC is this one minus this one. So this one, you know, it's A by 2. Right? Lovely. So then you get what? You get so now you need to find out this whole angle. QAC. How do you find QAC? QAC, oh yeah. QAC is now wait a minute, there's some stuff over here. 180 degree plus A by 2 minus this. Just give me a minute. Something wrong. So we have found that this angle is 90 degree plus A by 2. Okay. Say by Q, QAC. Oh yeah. Yes. So observe QAC. So this is right angle triangle, right? So this is 90 degree. So this is C by 2, right? So this is what? This is 90 degree minus C by 2, right? Yeah, lovely. So what do we get over here? We get that QAC minus IAC. Angle QAC minus angle IAC. QAC we got that it's equal to 90 degree minus C by 2. And IAC I have got it's equal to A by 2 minus A by 2. So what do you get over here? You get that essentially it's equal to B by 2. So therefore, this angle is same as this angle. That means QR is parallel to BC. All of you understood this stuff, guys? Can you understand? Can you see this now, guys? So we are. Can you see it now, guys? So we have this corresponding ideas over here. We have got PR is parallel to BC, QS is parallel to BC, and we have got QR is parallel to BC. Okay, it's a big problem, it seems. So we have to understand that first, this is the proof of PQRS is a are collinear. Now we need to prove that if PQ is equal to 7, QR is equal to 6, and RS is equal to 8, what is the area of triangle ABC? Okay, that's what we're trying to prove now. Okay, so what do we do now? What do we do in this now? So we will try to find out now in terms, we have got a lot of rectangles. So we will try to find those stuff in terms of the actual sides. Okay, in terms of the actual sides. That's what we are trying to prove now. So let's remove all this stuff over here. Let's remove all this stuff. It looks a bit ugly. Yeah. So if you remove this, we have got this is a rectangle. This is a right angle triangle, and all this lie on here. We have got. So therefore, what do we get? That peak R is actually, so this is a midpoint of both, right? Right angle triangle. These are like this cut and midpoints. You all know about this. These are the midpoints. You know about this, right? These are the midpoints of this whole thing. So therefore, we can easily understand from here what are the possibilities of. So what are the information? What are the information given over here? Let's check. Information given over here is PQ. Let's see what is PQ. Okay, PQ is equal to 7, QR 6, RS 8. Okay, lovely. So 7, 6, and 8. Lovely. Okay, that sounds good. So let's see how we can do that. So all of you know RS is parallel to BC. Okay, so RS is parallel to BC. QR is also parallel to BC, and PQ is also parallel to BC. So let's try to find out PQ in terms of all these. Okay, let's try to find it out. What's all this? So the in a quadrilateral, understand, remember very carefully, the diagonals are equal and they equally bisect each other, right? That's a quadrilateral property. So suppose let's remove this stuff. So if these are quadrilateral, what do we get over here? That let's say AB ka length is C, right? AC ka length is, BC ka length is B, and AC ka length is, so BC ka length is A and AC ka length is B. Okay. So therefore, length of PR is also C. Length of QS is also B, right? So that's what we know till now. Okay. Fine. So what will we find over here? If we need to find the PQ is equal to this. So let's name it. Okay, let's call it A, M, N, L, O, P. Okay. So we'll try to find equations in terms of. So m plus n, sorry, m is equal to, m is equal to 7. We all know that. We've got it. M is equal to 7. Let's write the equations over here. So m is equal to 7. We have given the information. QR, that is n plus L plus O, is equal to 6. And RSP is equal to 8. Okay. So we know that m plus n plus L plus O is equal to C. We also know m plus n is equal to half. Yeah. Let's try to use these properties. M plus n is equal to L plus O is equal to C by 2. Similarly, O plus P is equal to n plus n. O plus P is equal to n plus L is equal to B by 2 because this of the rectangular properties. So from here we need to find what? We need to find, also we have L is equal to B by 2 by midpoint theorem. L is equal to B by 2. Sorry, A by 2. It's becoming a bit dirty over here. Let me rub all this stuff off. It's become a bit dirty. Let me rub all this stuff up. So we have got that m is equal to 7, n plus L plus O is equal to 6, P is equal to 8. Okay, and from the diagram we got m plus n is equal to L plus O is equal to C by 2, and O plus P is equal to n plus L is equal to P by 2. And also we have got that L is equal to A by 2. From this, what we need to find? We need to find A, B, and C. Okay, in terms of M and M and P. So replace M and P over here. So we got, first replace M over here. Only one M. So M is equal to 7. So let's rub it off from here. Let's replace P is equal to 8. P is here. So we got P is equal to 8 over here. Let's rub P from here. So therefore we need to use this information. N plus L plus O is equal to 6. Oh, lovely. I can easily see it from here that n plus L plus O is, so therefore understand it from here that this implies that 7 plus n plus L plus O is equal to C by 2, and this is equal to, sorry, C, and n plus L is equal to 6, it's equal to 13. So C is equal to 13, you get. So now B, again n plus L plus O, so 8 plus n plus L plus O is equal to B. So you get it's equal to 6, 14. Lovely. And A is equal to A by 2 is equal to L. Okay. So we got these equations now. So you can easily find out L, I guess, now. So n plus, okay, so n plus L plus O is equal to this, B is equal to 14. So you know that L plus O is equal to now, C is equal to 13. Okay, I think it's not really hard now. C is equal to now 13 by, so therefore replace 13 by 2 over here and B as 14 by 2 over here. 14. So you get from here what is the value of L, I guess. Yeah, I think that's hard. So N is equal to what? It's called, oops, there's some mistakes, I guess. Are there some mistakes, guys? There shouldn't be any. Yeah. PR is equal to AB because of the rectangle. In a rectangle, the diagonal lengths are equal. Did I do some mistakes, guys? I think I did some mistakes. Some mistakes I have done. Did do the QR is 6 and RS is 8. No, it's M squared. N plus M plus N plus L. 7 plus, okay. So this is equal to 13. And you have got 14 over here. Need to know the length of L actually. So M plus N is equal to 7 plus N is equal to 13 by 2, 6.5. Some तो mistake हुआ होगा. What mistake did I do? B should be 60. B should be 15. B is coming out to be 15. There's some mistakes. Some to mistake hai. I have done A and B correct. कुछ तो mistake है. BC is 14, AB is 13, AC is 14, BC is 15. It will turn out. Okay. Let's see. 13 by 2 is equal to 7 plus L will come out. Okay. L will come out to be 5. Hello. What is the problem here? It's occurring. Sure. M plus way to find L. 14. 7 plus we have got M plus N is equal to half of AB. AB we have got it to be 13. कुछ तो गड़बड़ हुआ रहा है यहाँ पर. What is really happening? Let me check. Oh, I see now. I think there's a mistake with this problem. From this equation, you can actually get, 7 is equal to L minus A plus O minus N. You get, and you get that 8 is equal to L plus N minus O. You get. If you add this up, you get twice L is equal to 15. You get A by 2 is equal to, I mean, from here it means A. From here you get A. But here observe that essentially it is not happening. Like M plus N is not half of this. So I think this problem is wrong. This problem is wrong. Maybe because O is turning out to be -1 and N is turning out to be minus 0.5. What is happening? Am I doing something wrong? Who knows? I'm not getting it. Anyways, I have given you the solution. I am not sure about it. Let's check. Okay, anyway, so here is a solution for you. So we have got the solution from, using Heron's formula, you can really get the solution. Yeah, so okay, fine. See you in the next class with the remaining problems. Let's see when we can complete all the problems together. Okay, bye bye and good night. Oh, I told the problem is wrong. I'm not sure because observe that n is coming out to be negative and O is coming out to be negative. Although we can find out L from here and A from here, we can get ABC, but N and M are coming out to be negative, which is not really possible. I don't know why this is coming out. I'm not sure. I have to check it. Anyways, okay. So bye bye and see you in the next class.